My name is Amos Winter, and I'm an assistant professor of mechanical engineering at MIT. My research group is called the Global Engineering and Research Lab, and it goes by GEAR Lab for short. And what we do is try to read the unique technical and socioeconomic factors of emerging markets, reflect on those as engineers, and then use machine design and product design research to create high-performance, low-cost solutions that work in poor countries and rich countries alike. One of our projects in GEAR Lab that we're working on is brackish water desalination, which means taking water out of the ground, which is salty, which is actually more prevalent than fresh water throughout the world, getting the salt out and making drinking water for people. Now the challenge for us is that we're trying to do it in locations that don't have electrical grid access. So we're having to use solar power. The end users I work with are typically people in developing countries, in emerging markets. And I have to be very sensitive, waltzing in as a wealthy Westerner and not coming across as, I'm going to come solve your problems for you. You know, that puts people on a very different hierarchy on the social ladder, you know, if I come on with that perspective. So instead, what I have to be very careful to do is come in with the perspective of, we are partners. You know, you as an end user, you have as much or more valuable information than I do. Even though I'm a trained engineer, you know about your life, you know about your problems, you know about your wants and needs. And I try to connect on that level. The design process is deciding you want to create something new, articulating what are you trying to satisfy, what are the requirements that must be satisfied for the solution, generating ideas for how to achieve that solution, first on a high level, thinking about strategies you could take, and then on a more detailed level, thinking about the actual embodiments and concepts that could reach that solution. Then breaking down those concepts into smaller, more manageable parts where you can solve each part one at a time, and then bringing those parts back together to create a full solution. And so what this process enables you to do is take a big, intractable problem and break it down into manageable chunks and then assemble it back into a solution. So for example, nobody ever sat back and said, I'm gonna picture a space shuttle in my mind and I can know exactly the bolt size that I can use in the thruster. Like, nobody can think at that level of detail. I look at the design process as being similar to operating like a detective in that I'm always looking for clues behind what are requirements for a design and what are constraints. I think the best analogy to a clue is a latent need. When somebody's telling you about a problem in their life, but not articulating a solution, and you have to extract from what they're saying, what is their problem that I have to satisfy? Classic example is when Henry Ford started designing cars. He said, if I asked people what they wanted, they would have said faster horses, because people's context of travel was around horses. But that latent need they were expressing was, I want to go from point A to point B faster. So you don't necessarily have to use a horse to do that. You could use another device, which became the car. I've done a lot of work on wheelchair designs. And I've done particularly a lot of work on wheelchairs for rural areas of developing countries. And nobody ever said to me, I want a wheelchair that goes fast and efficiently on rough terrain, that's small enough to use indoors, that's repairable in a village area, and that's low cost. What I heard instead was, boy, it's really hard to get from my house to my job. Or, geez, my outdoor wheelchair doesn't fit in my home. And you get a sense of these latent needs, which aren't expressly expressed, but are very important. And if you can get some insight into those needs, you can incorporate them into your design. At the beginning of a design process, what I try to have the students do is understand the constraints and requirements behind the problem they're trying to solve. Constraints are things you cannot change about the problem. You know, it may be that there's water present in the environment, or there's a fixed price point that people will buy a product. There's requirements as far as like weight and cost that you have to meet for that product to be successful. And then the other thing I try to have them realize is what I call design freedoms. And these are the opposite of constraints. These are things naturally occurring in the environment where you're designing that you can use to your advantage. So things like low-cost labor or solar or sun energy for solar power. In that early stage of design, I try to have them lay out that whole environment and landscape behind the problem to see what their options are and see which different strategies they can take to embark on a solution path. All the classes I teach at MIT are around making things. And all the things we make benefit from the design process because they usually start with really tricky problems that we can't think about as a whole. So we have to break them down into parts. And they're all such that we have to understand the requirements, we have to generate a lot of ideas, we have to evaluate those ideas relative to each other, and then we have to assemble all the parts of the design back into a physical final thing. So I think this, this perspective on problem solving is really important to impart on students. So if they're solving, building a shed at their house versus making a space shuttle, they can apply that same process of breaking down the problem, generating a lot of solutions, evaluating them, and putting them back together into a design that they're confident in. As a teacher of design, I feel like I'm a catalyst. Like I'm trying to encourage the students to do design thinking. I'm always pushing them to create more ideas. And I spend a lot of time trying to guide them through the process. The worst thing I can do is just sit back and try to solve their problems for them. I don't want to do that. I want to empower them so they can think of their own ideas and go through the process and be confident at the end that what they result in their design actually works and actually satisfies what they set out to do in the beginning. If you're going to conduct an interview, you want to go in with as few preconceptions as possible. You don't want to lead people to an answer. You want to ask them questions about their life and get their perspective. You want to treat them on an equal plane as yourself, or even higher plane. Depending on the culture you're working in, oftentimes people will be very polite and not argue with you. And so sometimes I actually have to say, no, please be critical of what I'm saying. Please be critical of my designs, because only with that feedback are you going to make it better. Feel free to rip it apart. You're not going to hurt my feelings. You don't want to come in with a perspective of, I am designing for you. You instead want to come in with a perspective of, I'm designing with you. I want to know your knowledge about the problem. I want to know your constraints and requirements. I want to acknowledge the value of that knowledge in comparison to my knowledge. And I want to show you that together, by combining our knowledge, we can produce something better than either of us could have done alone. And just coming in with that perspective and mutual respect goes a long way in engaging an end user and getting honest feedback from them.